Now let's finish by writing our customer class. We'll correct a typo here and then proceed. A customer will have two attributes. One is end time, but this will be set inside the bank's start customer method. The only other one is the one that we used here, transaction time. This is the amount of time that the customer will need at the bank. The problem statement tells us this is a random amount between 1 and 5 minutes. We know the customer will always need at least 1 minute. The additional time they need will be anywhere between 0 extra minutes, 1 minute in all, and 4 extra minutes, that's 5 in all. So we'll get a random number and multiply it by 4. The smallest this can be is 0 times 4, that's 0 extra minutes. And the largest it can be is 1 times 4, or 4 extra minutes. This is the number of minutes, and it's some random amount between 1 and 5. But we'll need the transaction time in seconds. So we'll multiply by seconds per minute. Now we have a formula for the number of seconds the customer will need. And this corresponds to any amount of time between 1 and 5 minutes. But when we check to see if the end time is the same as the bank's time, this will need to be an integer so that it matches exactly with the number of seconds here. But here, when we get the transaction time, we're getting a floating point number. Remember that this is any fraction between 0 and 1. So we'd better turn this into an integer right at the beginning. Now the transaction time is an integer number of seconds corresponding to any amount of time between 1 and 5 minutes. Finally, we're ready to run our simulation. Remember that we'll be running 10 simulations, and in each one printing the average length of the line. Here we've used lowercase false. Let's fix that and try again. We can see that the line length is on average a little long. The shortest it is on average during one day is about 2.5 people waiting. And on a bad day the line might get as long as almost 10 people. But we can get some more mileage out of our simulation program by changing parameters. To take just one interesting example, suppose instead of 20 people arriving per hour for service, it's 25, just a few more. Now watch what happens to the line. Now on an average day, during any time during the day, we can expect to see 15 to 20 or even 30 people waiting online. This shows that at 20 customers per hour, the bank is just about at capacity. If a few more customers start arriving each day, it will definitely be necessary to add another teller. We can also use this program to find out on average how long customers wait while they're standing on line. But we'll leave this for another time.